So, good morning. Today I want to talk about synthetic data. And the reason for that is because I recently listened to a podcast about synthetic data. And it is a quite compelling or interesting approach to meet regulations and especially data privacy. However, what I wanted to address today is that synthetic data has rarely a use case that actually helps in building a model, a classifier, to provide some solution to a certain real life problem. And I want to elaborate why that is. So first of all, when we talk about synthetic data, let's have a quick Wikipedia search or definition. And it says synthetic data is any production data applicable to a given situation that are not obtained by direct measurement. And yes, so that's basically the first sub-sentence here. And in context of privacy protection, the creation of synthetic data is an involved process of data anonymization. That is to say that synthetic data is a subset of anonymized data. So there are a couple of things that are mixed together here. So the first thing I want to elaborate is, or I want to suggest you is to think about what synthetic data is, or what data in general is. Data is more or less a representation of information from the real world. So what we are trying to do in machine learning, artificial intelligence, statistical learning, whatever, we are trying to find knowledge or information from data that is already in the world. So as you might know, as a practitioner of machine learning or data science, you might be aware that there is always, basically, or nearly always, some data cleaning to be done, data engineering to be done. And especially when you try to model something out of the real world, even gets more important to understand the data first before you build a model towards it. So in essence, a model or a classifier tries to model the real world. So therefore, and this is in data science, data analysis, machine learning, AI, this is always the most important thing. What type of classifier you choose is not that important, but it is important what type of data you use, how you clean and engineer the data, and how you subsequently transform the data. There can be multiple issues in transforming it, but you will introduce an incredible hard bias into your model when you use already data that is not a representation of the real world. And this is the problem that I right now have with synthetic data approaches, because they try to sell you something like privacy, they try to sell you being compliant to whatever regulation. However, they model a data set that is not reality. So let's quickly capture this here on a notepad. So when I have certain data points, let's say we have various data points here with various data points. And what the model tries to do, the model is trying to separate, let's say we have a classification case here, try to separate certain data points. That's what we like to do. So the model, so there we have the data. And the whole scenario here is, let's call it real world. And then what we can do then is we can use that model data to do some prediction or classification classification or whatever, right? So what we would like to do is we want to use information, we want to use that information here to accomplish a certain goal here. And in this pipeline, you can have so many ways of problems, or so many errors that will just lead to a worse and worse prediction, right? So let's try that case with synthetic data. So when you have synthetic data, this is already not a real world. This is already created with various methods and algorithms that should model real data. So instead of having the pipeline going from data to model and prediction, where we say, let's have 0, 1 as a representation of a classification. So in this pipeline here, in between this step, you will have, if we consider this now real world data, so let's remove that, and let's consider this real world data, then in between you will have, let's take a red one here, you will have here synthetic data. And now what you need to do basically is you need to transform real life data, real world data, into synthetic data, and then build the model on the synthetic data to have the prediction. So, and this is the fundamental problem that you will have when you use synthetic data. When you, as a machine learning practitioner or data scientist, you will always only have this area here to work with, but you do not have any idea about this area here. And this is a fundamental issue, a fundamental flaw that you will have as a person that works with data, because as I said before, the most important thing when developing machine learning models or prediction, statistical analysis, whatever, is always quality of data. The quality of data is the most important thing. So if you already start with something like this here, modeled data, or approximated data points, then you will already work with a heavily biased data set. I'm not talking about imbalances. I'm not talking about having too little data points. I'm talking about an already biased data set. And this is already a problem if you want to work with it. So let's have a real world example, or let's just go through the pipeline once to illustrate even better what I mean with that. So let's say we have personal information. Let's say we have information about persons, about people, about their behavior, and various life or consumerish traits that you can associate to those customers. And you want to predict their behavior in the economy. So we want to predict, maybe let's have this in green, behavior in economy. So if you take real data, let's say their spending behavior. Let's say we have a concept where customer need to show their card. They need to show their card when they pay. And then you gather this information. You gather information about their spending behavior. Then what you have again real world data, and this is great. However, you now as a company, you cannot easily share that data, at least not in the European Union, because most often, this real-world data is infected with personal identifiers, meaning that if we have, let's say, Max here, you know Max is, let's say, 30 years old and buys, I don't know, he buys burgers and he also buys porn. So now we have personal identifier like Max, and his surname is Maxwell, let's say. So you have this information, you have his birth date, it's the 1st 19. Okay, now I have to do with the calculation back. So let's say it's 1992, right? And you have this certain information. So you, as a data scientist or machine learning practitioner, you're interested in, what does he buy? Maybe what is his year? And what is his gender? So gender is male, let's say. You're interested in that, but however, you cannot use this because this is a personal identifier, so you would know that this is Max Maxwell. So what synthetic data now tries to do, let's say, okay, we have Max, but what we want to do is we do not want to have this information. So there are multiple approaches on how you can pseudonymize or anonymize data sets. But right now we are not talking about that step because that's a different story. What we are talking now is synthetic data. So we create an own data set out of the original one. And then what you would need to do now, you would need to create an own model that models this data here with accuracy or whatever metric you like to have, 100%, because you rely for the further models on this synthetic data. So you would need to have 100%, whatever your metric is, or near perfect keeping the rules for the information of the original dataset into the synthetic dataset. And when doesn't matter what classifier you use, what model, doesn't really matter. You do this. How do you do this? You do this with certain rules. So you have a couple of rules. Doesn't matter what you use. You have a couple of rules, and your machine learning or your model uses those rules to determine the creation of the new data set. So if this model now, the creation model, has a fundamental error, a fundamental flaw, or any error, you will just copy all that error into the synthetic data set. So let's say we have, let's have it here, we have error here. So instead, so he does, the model works nice, but instead he associates, let's say, porn with burgers. So let's say every male has a high probability of buying burgers with porn. Burgers with porn, burgers, porn, male. So male. So this is now somehow encoded into the model for the synthetic data. So now you have the synthetic. Let's have it again in red. Now you have the synthetic data that has this information modeled. However, let's say this was an outlier, or it wasn't an outlier. You never know. You have multiple outliers. But your model somehow inferred that information with this rule set and deemed it to be accurate, because you when creating the synthetic data set, you tune your model, right? You determine as an engineer when the model is good. So you will encode this information here, this weighing of these parameters in a specific way in the new data set. And now what you have, what you can now do, you can now share the data set to other companies, because you are GDPR compliant, no Maxwell, no birth. Because your creation of the synthetic dataset allow you to name it whatever. He can now be called whatever. Doesn't matter. Also the birth, I mean, depending on the algorithm that you created, this can also be transformed or not. That's upon you as an engineer. However, now let's say we accomplished all of that, and now we are compliant, which is nice because now we can share this information and dataset. However, so now let's say I am a company and I want to have this consumer behavior of a person. So now I have the data, and I create a new model. And predict good or bad, whatever that means now. So let's assume that you are a very good machine learning engineer. You are one of the best, and you tuned your model really nice. So everything is great. Your model performs well. So the underlying issue now is that you have a fantastic model that models not reality, but the approximated reality. And it's not really virtual reality, but it's an intention that you model here. So you intend here in this step, you intend to model the real world data set as good as possible, keeping all the rules as good as possible for the synthetic data set. However, and this is now the final point to drive home here, you model according to certain things you want to have when you create the synthetic data set. You want to have all the information as much as possible, but you cannot have the information in certain aspects. And limiting this modeling of the real world to a certain degree limits the quality of the output dataset, of the synthetic dataset. Because you inflict rules into a representation of reality that is not the reality anymore, because you inflicted already some rules. Sometimes that's quite easy. Let's say for data privacy, that's an easy case. Let's go very simple. Let's say you do not want to have the name, the full name. You do not want to have that. So by the rule of stripping away this name, you already change the data set to such a degree that it might lose information subsequently to be useful for a machine learning classifier. So when you use synthetic dataset, be careful on how you work with it. Be very careful and be very aware of how the synthetic dataset is created, and always ask about biases. Ask about biases, what the creators of the synthetic dataset had in mind, and what information might be missing. So in terms of data privacy aspects and thoughts or perspective, that can be quite easy. However, and I do not want to get into details here, but I think it's a very important point to make, is that data privacy is a little bit more complicated, because it is not enough to simply strip away the direct identifiers, but also the combination of multiple personal identifier, quasi-identifiers. And if you remove those parts, those information on a particular rule set, a bias, you will have this bias in your classification, regression model, whatever you use it for. So the chance that you develop a biased model when using synthetic data is very, very high. Not only talking about data privacy, but any synthetic data set. Yes, so this is my current, those are my current thoughts on this topic. So feel free to comment on it, share with me your thoughts. I just wanted to put this out because I've seen it so many times now, and then I see people using synthetic data and they cannot get any proper results out of it. One thing to note here is that I do not mean augmentation of real data. So that's a different story. If we talk about computer vision and image classification, there are certain augmentation styles and principles you can easily use, and you will not worsen your model quality. But I'm talking about companies that promise you synthetic data approaches that model real world data, and promise you that you will have an as close as possible data set to reality, but with all the upsides, all the advantages. Because until now, I did not encounter any of those data sets, and I'm happy to see it happen once. And yeah, I'm happy for any discussion. So that's about it, and thanks for listening.